Good afternoon, my dear students. So today in the sessions we are going to learn 13th problem on the helical compression spring. Okay. The first of all, I will read the question. The load on oil tempered carbon steel helical compression spring that varies from 600 to 1600 Newton. So this means that the maximum compressive force is acting on the helical spring is 1600 Newton and the minimum compressive load 600 Newton is acting on the helical compression spring. Okay, so the maximum load we have to represent as F maximum is equal to 1600 Newton is load is acting on the helical compression spring, as well as the minimum load is 600 Newton is acting on the helical compression spring. The mean diameter of the coil is to be 60 mm. So here the mean diameter D is given as capital D is given as 60 mm, and the desired design factor of safety is given as 1.3. Factor of safety, how much is given here? 1.3, based on the available stress. So in this case, what we need to be determined? We need to determine the wire size. We need to determine in this problem. So let us take tau y. Tau y nothing but yield stress. Yield shear stress is given as 700 mega Newton per meter square is given. Then how to solve this problem? Let us see. So in this case, the carbon steel helical compression spring that varies from 600. So this means that 600 to 1600. The minimum load of how much is there? 600 Newton. The minimum load is acting on the helical spring is F minimum is 600 Newton. The maximum load acting on the helical spring is F max. Maximum force or maximum load is acting on the helical spring. How much is given here? 1600 Newton. The first of all, we need to find the mean load. So mean load, we have the formula is FM. FM is equal to maximum load plus minimum load by 2. Maximum load plus minimum load by 2. So the maximum load it is given in the question is 1600 plus the minimum load it is given as 600 by 2. If you are calculate with the help of calci, then you will get the answer of 1100 Newton. That is a value of mean load. Okay, after the getting the value of mean load, we need to find out the value of variable load. So what is the difference? So just you know very well how to represent this formula. Variable load equal to maximum load here minus minimum load by 2. Okay, so this variable load it's represented by FA. FA we can say as amplitude load, or FV we can say as variable load. Okay, FA what we can say? Variable load. Okay dear, the variable load equal to, here the maximum force is acting on the helical spring is given as 1600 Newton minus the minimum load is acting on the helical spring is given as 600 Newton by 2. So if you subtract or as well as if you divide, then you will get the answer of 500 Newton. So after the getting of the variable load, we need to find out the mean shear stress in the spring. So the mean diameter is already given in the question. How much? 60 mm is given. The factor of safety how much is given? 1.3 is given. Okay dear. After that, what we need to find out? We need to find out the mean shear stress in the springs. Okay, so the mean shear stress in the springs is equal to 8 mean force into mean diameter into K nothing but Wolf's factor by pi into dq. So in this case we know the value of Fm as well as we know the value of D, but we don't know the value of K. Is it right? As well as we don't know the value of d cube. Keep as it is. Let us see it as it is. Fm value, how much we got here? Fm value is 1100 Newton into d, how much? 60 into k by pi into d cube. Then 8 into 1100 into 60 by 3.142. If you divide, then you will get the answer is 168067.62. K as it is as well as d cube as it is. After that, we are from this mean shear stress, we are not getting the value of k and d cube. Please keep as it is. Okay. After that, the variable shear stress in the springs, or we can say as amplitude shear stress in the springs, tau a is equal to 8 Fa into d into k by pi into d cube. So if you want this equation of variable shear stress, we have referred the page number 139. Equation number is 11.18. Okay dear, 8 as it is. So here variable force, how much is given here? 500 is given, and the mean diameter, how much is given? 60 is given into, we don't know the value of Wahl's factor. Keep as it is by pi into d cube as it is. Okay, after that just you need to multiply this term 8 into 500 into 60 by the value of pi is 3.142. If you divide, then you will get the answer is 76394.37. K as it is as well as d cube as it is. From the variable shear stress also we are not getting the value of k and d cube. After that we need to proceed. So for the oil temper wire, the ultimate tensile stress value, how much is given here? 1070 meganewton per meter square. So if you refer the table number 11.5, page number 190 from the design data handbook, then you can easily get the value of ultimate strength as well as ultimate shear stress value you can easily get. Okay, after the getting of this ultimate stress as well as ultimate shear stress, as well as for a high carbon steel, for a high carbon wire, the ultimate stress value is 1070 Newton per millimeter square. After that, if you are getting the ultimate stress, what we need to find out? We need to find out the endurance stress. We need to find out. If you want to find out the endurance stress, we know the formula of endurance stress is equal to ultimate stress by 2. So here the ultimate stress value, it is given as 1070 by 2. If you divide 1070 then you will get the answer is 535 Newton per mm square. Okay, so because the ultimate stress value is in Newton per mm square, so the 2 is not having any unit, is it right? By 1 the remaining should be how much? What will be the unit? The unit should be Newton per mm square. That is the unit of endurance stress. Okay, after the getting the value of endurance stress, you need to substitute this value of sigma u and tau y as well as sigma en in the Soderberg equation. So 1 by n is indicate that this n is indicate that factor of safety equal to the mean stress. Tau m is indicate mean stress by tau y is indicate that yield stress plus variable shear stress into K is the Wahl's factor into Kf is the stress concentration factor by tau E. So endurance shear stress into K surface finishing factor into K size finishing factor. So in this case we know very well, because the K surface finishing factor value is not given, K size factor value is not given, as well as stress concentration factor value also not given. If it is not given, then you need to consider the value of 1. You need to consider the value of 1. Okay here, 1 by n as it is. Okay, 1 by n, nothing but how much factor of safety is given here? The factor of safety is given as 1.3 is given. Okay, 1.3 equal to the mean stress. How much we got here dear? Let us see. Mean shear stress we got as 168067.62 into K by d cube. So please keep as it is here, replace here, and tau y, the tau y nothing but how much, 700 plus amplitude shear stress value, how much we solved here, the amplitude or variable shear stress in the spring is, we got the value is 76394.37 K by d cube. You have to replace here, and K as it is. So stress concentration factor value here not given in the problem. If it is not given, then you need to consider the value of 1, okay, by. So endurance shear stress, how much we got here? We got the answer is here 294. Okay, here, so from here, so endurance stress is equal to 0.55 into sigma into En. 0.55 as it is, sigma En is endurance shear stress, or we can say as endurance limit stress. How much we got? 535. After getting the 535, just you need to multiply 535 into 0.55, you will get the answer is 294.25 Newton per mm square. That is the unit of endurance shear stress. Okay, after getting the value, this you need to substitute here. K surface finishing factor value is 1, K size factor value is 1. So just first of all, you need to divide this term 76394.37 as it is, okay, by, so this bottom terms it's move above, it will become as 294.25 into d cube, okay dear, and the same as it is also 168067.62 K by 700 into d cube. So we need to observe here which terms is common. So here in this case, K and K is constant common here, as well as d cube and d cube is common here. Just you need to remove from the bracket K by d cube. The remaining terms we have to represent in the bracket. The 168067.62 by 700 plus 76394.37 by 294.25. So if you divide the value of 168067.62 by 700, then you will get the answer of 240.0966. Plus if you divide the value of 76394.37 by 294.25 with the help of calculus, then you will get the answer is 259.62. So just first of all, you need to add this value 240.0966 plus 259.62 with the help of calculus, then you will get the answer of 499.71. After getting the value of 0.7692, just you need to divide this constant term, okay, 0.7692 and 499.71 also constant, just you need to divide here. After the dividing this whole the value with the help of calculus, then you will get the answer of 0.00153 equal to K by d cube. Just we need to assume this value, okay, keep as it is, K by d cube, that is the desired equal to 0.00153. After that, in the trial one, we need to assume this spring index equal to 7, okay dear. Spring index C is equal to capital D by small d. The capital D nothing but this mean diameter of the coil or mean diameter of the spring, by these indicate that diameter of the spring. So is here the C is the spring index value is given as 7 is equal to capital D, already given the questions, 60 by D. So D equal to 60 by 7, then you will get the answer of 8.57 mm. After getting the 8.57 mm, okay dear, let us see. After that, we need to find out the value of Wahl's factor, because we need to find out the value of this K as well as we need to find out the value of D also. Is it right? So K is equal to 4 into spring index minus of 1 divided by 4 into spring index minus of 4 plus 0.615 by C. So 4 into C is the spring index value is 7 minus of 1 by 4 into 7 minus of 4 plus 0.615 by 7. If you divide the whole the value with the help of calculus, then you will get the answer of 1.212. Okay, so this k by d cube we need to assume. Okay, so we know the value of k is how much, 1.212, keep as it is, and d is how much, 8.57 whole cube equal to 0.0153. I hope so no one is having a doubt, because in this case what we need to find out, we need to find out the value of d. We already have found out with the help of trial method. Okay dear, I hope so no one is having the doubt regarding the sessions. If you have the doubt regarding the sessions, please write down in the comment box, and please don't forget to subscribe my channel. Thank you.